Summer 2012, Paper 2, Calculator. The distance time graph of a journey. And the important thing to realise about a distance time graph is that the gradient equals the speed. So we can see in the first part of the journey we have a constant speed moving away from home. We have a speed of 0, so we're staying in the same place, and then we have a constant speed moving towards home. So when we're looking at how we can tell that it was greater going to the store, and that would be because the gradient of the line is steeper. You could also answer this question by considering the time that has taken, because the distance that we're travelling is the same in both. And what we can see at the start is that the time is much shorter than the time at the end. So an alternative answer here would be that the time is less. You only have to give one. We're then asked to find the average speed on his journey to the store. I'm going to start by looking at the units. And it's important to know here that distance is going to have to be in kilometres and time is going to have to be in hours. We have a speed, distance, time triangle. And if we want to find the speed, we cover that up. And that leaves us with speed is distance divided by time. The distance is 8 kilometres and the time is 15 minutes. And 15 minutes is 1/4 of an hour, and it is important to work in the decimals. And 8 divided by 1/4 gives us 32. So we have Bob's wife leaving home at a speed of 24 kilometres per hour. Again, if we go back to our speed, distance, time, this time we're interested in time. So time is distance divided by speed. So that is 1/3 of an hour, 20 minutes. So if she leaves home at 14:30, she will arrive at 14:50. So at 14:42, how far from the store was Bob's wife? And we can see from the line that I've added in that we have a distance of 5 kilometres, but it's important to note the question said how far from the store. That's the distance from home. So if we're 5 kilometres from home and the store is 8 kilometres away, then we are 3 kilometres from the store. Before answering this question, I'm going to consider the numbers on the dice. So we have 1, 2, 3, 4, 5 and 6. And we have the probability of getting a 2 is 1 and 6. But let's think about the probability of getting a prime number. It's important here to know our prime numbers. So our first prime number is 2, then have 3, then we have 5. So the probability of getting a prime we can see is the 3/6 or 1/2. Now we can only use the OR rule, which is the addition, if the events are mutually exclusive, which means they can't happen at the same time. So let's think about the probability of getting a 2 or a prime. 2 or prime, and that still is 3/6, 1/2. And Jennifer's incorrect, so is Jennifer correct? No. And that's because 2 is both prime and 2, therefore not mutually exclusive. Translation -6 minus 2 means take the shape and move it 6 squares left and 2 squares down. So if we take each point, 2, 4, 6 and 2 down. If we take our second point, 2, 4, 6 and 2 down. And if we take our third point, then we just need to join these up with a ruler. To do a rotation, we must always ask for tracing paper. I'm going to mark on the centre of rotation, it's at -10, and then we place the corner of our tracing paper at this point and trace over the shape, and I've taken an image of it. We want to go 90 degrees clockwise, so we take the tracing paper and we rotate it 90 degrees clockwise, keeping the centre or the corner of the tracing paper at our point. And then you won't have the same problems I'm having with resizing. Then take our pencil and make crosses at the new points. Remove the tracing paper and join those points up with a ruler. Mine are slightly off due to the resizing of the picture. I don't have a straight line tool, so make sure that you use a ruler, and this is C, and I forgot to label the first one B. Question 7 tests our rules of indices, and if we have two indices multiplied together, then we add the powers. So a to the power 4 times a to the power 4 will be a to the power 8, 4 plus 4. Whenever we are dividing, we subtract the powers. Now it's important in this question to note that b is actually b to the power 1. So if we use our first rule and add the powers, we have b to the power 6 on the top, and then we have b to the power 6 divided by b to the power 2. So that'll be b to the power 6 minus 2. That gives me b to the power 4. 3 I'm going to write out as a fraction. And we can see that 12 divided by 3 is 4. And then we have the 5 and the 7 cancelling. So we can give our answer as 4 over c to the power 2, or using our second rule, 4c to the power minus 2. 5 take away 7, which is minus 2. Finally, we have an inequality. It's important to remember with inequalities that the direction must not change. So I'm going to subtract 3x from both sides, which gives me that 5x is less than 6. And then to complete the question, I'm going to divide by 5. So x is less than 6 over 5.